simple case where a body has been dropped, it has been dropped from here and it rises to a height h by 2. Suppose this is the case. Now what we want is, the question is, what is the velocity that should be given, initial velocity that should be given, so that it once again rises to the same height. So that is the question. In case you give lesser velocity, it may happen that it strikes and slightly higher it comes over here. If you give much higher velocity, it strikes and rises to this height. So the question is, what is the velocity that is given so that it strikes and comes to the same level? So this is the question. What we can do is, from here, what is given is, that is, we know E is equal to under root of h2 by h1. h2 is the height it attains after the collision has taken place. Obviously this body has been dropped, so indirectly we have been given the value of E has been given. How E has been given? E is equal to h2 by h1. So E is equal to under root h by 2. It has been dropped, so we can use this formula. So E is equal to h2. h2 is h by 2 upon h1. This, so E is equal to 1 by 2. So E is equal to 1 by 2 raised to 1 by 2. We can say it like this. So now u velocity is given and we are asked, that is, we want that it should rise to this height once again. So now when u is given, let's find velocity over here, that is just before the collision. So just before the collision, what we can do is, we can also apply conservation of mechanical energy principle also. That is position number, this is position number 1, this is position number 2. So 1 to 2 if we go, then, and if we take this as reference level, then mechanical energy at 1 is equal to mechanical energy at situation number 2 when it comes over here. So what is that? That is potential energy 1 when the body is here plus kinetic energy when the body is here is equal to potential energy when the body is point number 2 plus kinetic energy when the body is point number 2. So this is potential energy over here is mgh plus kinetic energy is going to be half mu square, we have given velocity now, is equal to P2 when it comes over here 0 plus, let's say, half mv square, it gets cancelled. So this is the velocity with which this is going to strike the floor. Obviously, if it strikes the floor, this will rise, that is, velocity after collision is going to be E times velocity before collision. That is, velocity after collision is going to be E times velocity with which it has struck, that is this one. This is the velocity. What is that velocity? If you see, look over here. So this is going to be, so 2 goes over here, that is 2gh plus u square is equal to v square. So over here, v comes out to be this much. So v comes out to be under root 2gh plus u square, where u is the velocity with which it has been thrown in the downward direction and v is the velocity with which this is going to strike the floor, that is, v is the velocity just before the collision. So after the collision is E times velocity before the collision, that is E times under root 2gh plus u square, that is the velocity. Now what we do is, we use conservation of energy principle from 2 to position number 3, which is once again at a height h only. So now we are going from 2 to 3 and we are saying P plus K over here is equal to P plus K over here. Potential energy plus kinetic energy over here is equal to potential energy plus kinetic energy over here. Conservation of mechanical energy, once again, please understand that is when the collision is taking place, at that instant we are not using conservation of mechanical energy. There may be sound may be produced, there may be heat may be produced. It is only that is from here to just before collision we can apply conservation of mechanical energy principle, and once the collision has taken place, then from here to here the body rises and over there also there is conservation of mechanical energy. This is the point you should remember. So 2 to 3 over here, P 0 plus kinetic energy over here half m, what is the velocity over here? That is E under root 2gh plus u square half mu square, half m this velocity square is equal to over here potential energy mgh plus kinetic energy 0. P plus K is equal to P plus K between this one and this, conservation of mechanical energy. So this comes out to m and m, they get cancelled. So when you square it, so we can take 2 over here. So this, when you square it, it comes out to be E square 2gh plus u square, 2 has gone over here, is equal to 2gh. So this comes out to be e square 2gh plus u square is equal to 2gh. So u square comes out to be 2gh 1 minus e square. So this is a velocity that should be given to this so that this rises to the same height. And if you put the value of e over here, that is 1 minus e square, so e I think we had calculated. So u square 2gh 1 minus e square is what? 1 by 2. So this is u square comes out to be 2gh 1 minus 1 by 2, 1 by 2 only. So u comes out to 2 and 2 get cancelled. So u comes out to be under root gh. So if with this velocity, this is thrown in the downward direction, this will come back at the same height.